You're going to need a way to power your equipment if you're going to do electronically assisted astronomy or astrophotography. In this video, I'm going to go through the different options that you have in providing that power to your equipment. But first, I would like to ask you to like this video if you find it useful. And you may even want to subscribe if you want to see future videos similar to this one. One other thing is I will put links to all of the equipment that I discuss here today down below the video where it says show more. Now this video is part of a series of videos I call the 6 essential tools for getting started in EAA. You may want to check out some of those other videos here on my channel where I discuss how to choose OTAs, mounts, cameras, computers, and software for EAA. Before we get into the different power options, let's talk about how much power you actually will need. Now this is where a lot of people greatly overestimate the power consumption of their equipment. So let's start with mounts. Mounts don't use nearly as much power as most people think. Something like an AVX mount from Celestron uses maybe 5 or 6 watts. It's not until you get to a much beefier mount, like my software BISC Mighty or MX mounts, that you see power consumption around 14 or 15 watts. Now that's what these mounts will draw while we're tracking, which is what we're doing most of the time. And you don't need to overestimate the power to account for slewing because we don't slew all that often. But you do need to take into account the higher current during slewing so to make sure that your power supply can reach that maximum total current in those short periods where the mount is slewing from one object to the next. Now what about cameras? An uncooled camera uses about 300 to 500 milliamps at 5 volts. So that's only at 2 or 3 watts. Now if you add cooling to the camera, depending on how low you set the cooling level, the power consumption can go anywhere from 10 to slightly over 30 watts of power. So a cooled camera will draw a significant amount of power compared to an uncooled camera. Likewise with dew heaters. The dew heater on my 11-inch Celestron SCT draws anywhere from 10 watts at 50% power to around 20 watts at 100% power. Now smaller dew heaters will use proportionally less power. But by far, the biggest consumer of power can be a laptop. Laptops can run anywhere from 60, 90 to 120 watts depending on the vintage and design of the laptop. Now on the other hand, something like the ASI Air or a Raspberry Pi will only consume something like 4 or 5 watts of power. A mini PC, on the other hand, will use slightly more power. My mini PC tops out at about 12 watts. Now if you want to see more information on how to either measure or estimate the power consumption of your setup, you might want to take a look at this video that I produced addressing that subject. Despite the fact that most of our astronomy equipment runs off of 12 volts DC, you'll often see a slew of AC transformers providing power to that equipment. Sometimes the transformer is supplied with the equipment, and other times it's sold as an option. So for instance, here's a transformer that powers my software BISC Mighty mount. Here's another AC transformer that I might use to power the cooler on my digital camera. Another transformer that I would use to power my USB hub that supplies USB power to my camera and to other equipment. Maybe another AC transformer to power my dew heater. And finally, another AC transformer to power my mini PC. You can see we can end up with a lot of AC transformers. And keep in mind that AC transformers are only about 80 to 85% efficient. So you're throwing away 15 to 20% of the power. And if you're in the field, you need an inverter to convert the power from a DC battery into AC and then back again to DC, which is very inefficient. So I think there's a much better way to power your equipment rather than using AC transformers, especially when you're in the field but even when you're at home. When I'm at home, I prefer to power all of my equipment by using something like this regulated DC power supply from Pyramid. Pyramid is a very well-known brand that makes these 12-volt DC power supplies. They come in different current ratings. This is a 10 amp version. I also have a 5 amp version, and they come in larger sizes as well. What's nice is this is a very well regulated output. Pyramid supplies are pretty well known in the ham radio business, so they have a very good following, and I can highly recommend them. This is an older model. There's updated models out there. So I would use the Pyramid supply, which has either the cigarette plug or it has these screw-on connectors here. Either way, you can power it. I've had no trouble using the cigarette plug. It stays in there, it's pretty secure. Now, how do I power everything else with that? I prefer to use a power hub. So I use this Pegaus PowerBox Advance, which is both a power distribution hub and a powered USB hub. So I simply put the power from my regulated supply into the Pegaus, and from there I can put power out to all of my equipment. This has 4 DC 12-volt outputs. It also has 2 outputs with variable adjustment to use for dew heaters. It has an adjustable output here where the voltage can be adjusted over a range like 2, 4, 6, 8, and so forth. And that's designed to work with DSLR cameras. It also has 4 ports as a powered USB hub, and then a connection so that I can connect this to my mini PC. What's nice about this is you don't have to connect this to a PC to use it. You can simply plug and play. But if you do connect this to the PC, there's some very simple software that comes with this that allows you to turn on and off the power outputs, change the level of the power in these adjustable outputs for your dew heater and so forth. It also has a meter in here so you can keep track of how much power you have used. So I highly recommend this. I just have a little Velcro on it, and I Velcro it to the side of my mount, and then from there I can distribute all of the power to my equipment. Since I have a software BIS mount, I have through the mount cabling, and so I keep this down below by my mini PC. But it's light enough and small enough that you can actually mount it on the top of your telescope if you don't have through the mount cabling. Now, if you don't want to spend the money on something like this, you can get something much cheaper and simpler, such as this West Mountain Radio rig runner. Rig runners are also very well known in the ham radio business. These come with different numbers of outputs. This one here has 5 outputs, 1 input, 5 outputs. What I like about these is they use the Anderson power pole connectors, and each one of these outputs, as well as the input, are individually fused. So I have a 10 amp fuse on the input, and then I have a fuse appropriate to whatever device I'm running on that particular output line. And these things, this particular one is somewhere around $70 or $75. Put links to these as well. There are also Chinese knockoffs of these that you can find on Amazon, which sell for even less. And like I said, this one has 5 outputs. You can get them with more outputs. You can also get it with a powered USB output, and you can get it with a digital display as well, showing you the voltage. So there are a number of options to distribute power to your system, but this is the way I like to do it even when I'm at home. Now, what happens with something that doesn't run at 12 volts? Now, there are a number of pieces of equipment that you may have that don't run on 12 volts. For instance, my software BIS mounts run off of 48 volts, so 12 volts is not going to cut it. But it's very simple to deal with that. I use one of these DC to DC boost converters. This takes 12 volts in and gives out 48 volts on the output side. So I've been using one of these for years with the 12 volts coming out of one of these ports to power this and transform it into 48 volts for my mount. In fact, I even use this at home rather than use the transformer, just because I like to use the same equipment at home as I use in the field. Now, some people have these mini PCs or Intel nukes that run off of 19 volts. Well, you can find these DC boost converters as well that will transform the voltage from 12 volts to 19 volts. And this one here you see in its raw form comes with pigtails. I put my Anderson power pole connectors on this one, and you can do the same here, or put whatever type of connectors you like, and you can then run from a 12 volt supply to 19 volts on your Intel Nuke or mini PC that needs 19 volts. So there is no problem using these distribution hubs even when you're not using 12 volts on some of your equipment. These DC voltage converters are relatively inexpensive, like anywhere from 20, 35, maybe 40 bucks. If you want to learn more about DC voltage converters, well, you can take a look at this video I produced on the subject as well. So out in the field, we have to bring our own power with us when we don't have access to AC. And the power options I'm going to discuss here are all lithium ion based power options. I still use my power distribution hub, the only difference being that the input comes from one of these other power sources than my pyramid, which I use at home. Now, if I'm doing some EAA outreach and I'm only going to be out for a short time with something like my Celestron 6SE, I can use one of these very small portable power banks from Talent Cell. This is an 8 amp hour power supply, which can run my Celestron 6SE plus an uncooled camera for many hours while I'm doing outreach. And in that case, I might be using my laptop and running that off of its internal battery or one of these other power supplies. But this is good if you don't need a lot of power because you're not going to be out long, you're not running a cooled camera, you may not have a dew heater, and so forth. These come in different amp hour ratings as well. Now, when I go to an astronomy star party or go out with my friends for multiple nights out in the field, I need much more power than that, especially if I'm using the dew heater and a cooled camera. So the two basic options are a lithium iron phosphate battery, like this one here from Ampere, or a portable power station like the two I show you here. So let's talk about the 12 volt lithium iron phosphate battery first. This is a 100 amp hour battery from Ampere. Ampere has rebranded themselves as Lithium Time these days. Same company, same product, but changed the name. They also make batteries in many different capacity points, less than 100 amp hours and greater than 100 amp hours. I actually use a 300 amp hour Ampere battery in my RV, and I have this connected to the outputs of the battery with a cable that I made with Anderson power pole connectors on either end, and then I can use an adapter to connect that to the input of this Pegaus PowerBox distribution hub. The nice thing about this is 1280 watt hours. I can run for multiple nights without recharging this with my setup. Now, how long you can run obviously depends on how much power your system uses and how many hours in a night you are going to run. There are many other manufacturers of these lithium iron phosphate batteries that you can find on Amazon. I'll put a link to this one because I highly recommend it. I did a review, which you can find here on my channel if you're interested. And this sells for about $350, and you can use 100% of the rated capacity, and you can expect to get anywhere from 2,000 to 4,000 full discharge cycles out of this. So this is going to last you many, many, many years. So a big advantage of the lithium iron phosphate batteries over lead acid is they weigh about half as much as a lead acid battery, And as I said before, you can get 100% of the usable capacity out of these batteries. So you can get 100 amp hours out of this without damaging it. Whereas out of a similar 100 amp hour lead acid battery, you're only going to get about 50 to 60 amp hours out of it before you need to stop discharging it, otherwise you'll damage it. Now the other option besides the standalone lithium iron phosphate battery is a portable power station like the two I show you here from Jackery and EBL. Now obviously the portable power station is much different than a standalone battery. These not only supply 12 volts DC, but they have a pure sine wave inverter inside, so they can supply AC power as well. They can also supply USB power to recharge your phone, your tablet, and even in some cases laptops. They also have an internal power meter, so you can see how much power is being drawn. And they also have an internal solar charge controller, which enables you to plug a solar panel directly to the input of this to recharge this while in the field. Whereas with the standalone lithium iron phosphate battery, you're going to have to get a solar charge controller, which you'll put between the solar panel and the battery. Now typically all of these portable power stations have a 10 amp 12 volt cigarette output port like this one here, which is what I use to power my distribution hub. I've had no trouble with these things coming loose, but many of these portable power stations will also offer other outputs. This one has a pair of 5.5 by 2.5 millimeter outputs, and if you want to convert that to the 5.5 by 2.1 that we typically use, you can get a simple converter like this, and you can use this to power all of your equipment that uses 5.5 by 2.1 millimeter plugs. Now the Jackery also has a couple of additional DC output ports. These are 6.5 by 1.4 millimeter, and you can find adapters on the internet, and I'll put links to those to convert it to the 5.5 by 2.1 millimeter DC port that we typically use. Now in terms of cost, obviously the portable power stations will cost more. Something like this 100 amp hour battery from Lithium Time will cost you about 27 cents per watt hour, whereas this portable power station by EBL will cost you about 27 cents per watt hour. And the Jackeries are a bit more expensive since they've been around a long time and they have a very well-known brand name. Although EBL has been around as a battery company since the 90s, they only recently started getting involved in these portable power stations. And if you're interested in this particular one, which I think is a good buy at $500 for a 1,000 watt hour model, you can see the review I did on this EBL power station here on my channel. One other key difference between the standalone lithium battery and the portable power stations is the type of cells they use inside. So the standalone batteries use lithium iron phosphate cells inside, and those cells, as I said before, can be expected to give you at least 2,000 full discharge cycles. Whereas the portable power stations use something called lithium nickel manganese cobalt oxide, or NMC for short. And they use that because it has a much higher energy density, about twice the energy density of lithium iron phosphate. And that's to keep the weight down. And that's why you will see NMC cells in things like electric bikes, electric power tools, and maybe even in your Tesla electric car as well. Now the full discharge cycles on NMC cells is typically at greater than 500 full cycles. Now what that means is after you've run this thing from 100% down to 0% state of charge 500 times, you're not going to throw this away, but you're still going to have about 75 to 80% of the original capacity of the power station available. So 500 full discharge cycles is still a lot of cycles, and that's a lot of years of life in one of these things. So let's sum up. There are lots of options for powering our astronomy equipment. At home, I highly recommend something like this Pyramid DC regulated power supply. I also recommend you use something like a power distribution hub, either this one from Pegaus or the Rig Runners from West Mountain Radio. And out in the field, your choices are a standalone 12-volt lithium iron phosphate battery, which is the best bang for the buck, but will require that you have a solar charge controller, which is not that expensive, if you want to charge this with a solar panel out in the field. On the other hand, if you want the simplicity of plugging in your solar panel directly and you want to have the availability of AC as well as USB power, then one of the portable power stations is the right choice. So I hope you enjoyed this video. If so, don't forget to like it. You may want to subscribe so you can be alerted to future videos. You may also want to check out my website, californiaskies.com, for more content like this. And once again, I would ask you to use the links down below the video where it says show more if you want to make a purchase of one of the items I've shown you in this video, because that will help support my channel. Thank you.